Good afternoon, everyone, and welcome to a preview of the North America Smart Energy Week and hybrid microgrid technologies. So we're going to go over a little bit about what North America Smart Energy Week is and get into some of the nitty-gritty behind the expanded Smart Energy Microgrid Pavilion. There's some new things to SPI that we're going to mention throughout, and we won't go into as much detail. So if you do have any questions about those, again, feel free to ask. Brian or I will introduce shortly can answer those questions, or after this webinar, you can email one of us and we'll be able to take it back to you with some more information. So without further ado, I want to introduce Brian Patterson. Brian Patterson, he's the president and founder of the Emerge Alliance. He has 30 plus years in the electrical and electronics industry, and he's heading up our smart energy microgrid marketplace this year, where we're going to have a live on-site microgrid powering a few booths around the area with a lot of connected smart devices. So I don't want to steal all of your thunder here, Brian. I'm going to pass it off to you. And again, just for everyone else who wasn't here a little bit earlier, feel free to ask the questions in the Q&A area. We'll answer them at the very end of the presentation. Thank you.
Thank you for the kind introduction, Greg. All of that and $5 will get you a cup of coffee at Starbucks, I guess. But in the meantime, we did promise that we would do the preview of the Smart Energy Microgrid Marketplace, which literally covers everything from smart buildings and homes and industries all the way up to utility grids. But we're going to focus in on specifically what we mean by that. And if you recall, this is the third of a three-part webinar series. The first was called The Next Big Thing, the Internet. And that webinar is still available online, either from eMerge or from the Solar Power International website. The second in the series was a real-time transactional management of microgrid mesh networks. That also is available online in both those places. And if you're not sure where, we'll repeat that at the end of the program. But today's webinar, as promised, is a preview of the North America Smart Energy Week, and it's a focus on hybrid microgrid technologies. So you may recall from the previous webinars that we talked about the after 100 years of historic success with the current grid, why are we changing things, or why is there a need to change? Well, part of it's based on the entrance of some disruptors in the whole energy field. Clean, renewable energy and the drive for a better environment, storage of power, which is in a practical way and in large amounts, is something very, very new in the marketplace. The continued development of power electronics, particularly at the higher voltages and higher power levels. The whole IoT domain, the expansion of the internet now to not just handle and communicate between people, but communicate between things, and the continuing declining cost of embedding such computing in things. The electric vehicles on the scene, really we're seeing the beginning of the end of fossil fuels, with possibly some might call an exception to natural gas, which is still growing a bit. But in general, fossil fuels are on the decline and will still be continuing under pressure and cost and environmental concern. And the advent of big data analytics, the cloud, and all the things associated with the cloud. So what are all those disruptors trying what are the problems trying to, what problems are they trying to solve? Well, we do need more power. Power, it does work, and work creates wealth, and wealth creates well-being. We do want to use less fossil fuels. We want to find socially acceptable ways for moving power around, particularly electrical power. We want to directly address the growing problems actually of resiliency. And finally, we do need once and for all to address the approximately 1/3 of the world that does not have a regular access to electricity, which in today's day and age is almost unheard of. But in any case, what we also want, and what we're learning from the internet and our experience with it, is we want a smarter world. We want a world that includes an integration between the use of energy and the work we do and the intelligence that we share very fluidly through the internet. With smart energy, we really want something that is operationally similar to the internet, but includes smart metering of power and smart appliances and smart choices of energy, renewable energy, and things like that, in a much more flexible and resilient, if you will, self-healing infrastructure. So that's what we mean by an internet. We're looking for something that connects a lot of different power elements, electrical power elements together, some in smaller grids, some in larger grids, into this commercial, government, educational grid of grids, if you will, all that's using a common set of electrical and communication standards. But why microgrids? Well, microgrids, in a way, if you use a simile of the internet, are like personal computers were to the information system. The beginning information, it was just large mainframe computers, and most of the personal level stuff was not interconnected typewriters and stuff like that. But now we have the ability to produce power locally at an individual home, or even in an off-grid hut somewhere. So we can intelligently produce that power, and with the advent of storage, we can store it. And most of it is renewable power when you do it that way. So we want to be able to manage that in a flexible operating system, whether we're connected to a grid or not. By sort of having this distributed capability of production and storage and use, we will end up with greater resiliency and reliability. And because it doesn't have to get transmitted long distances in most cases, we may even enjoy a much higher quality level of power. It will operate more efficiently by being close to the sources like solar and batteries, and thereby avoiding the transportation and distribution of power through long lines and so on. Although we'll still use those lines for bulk communication, just like we do for information in the internet, still uses the original telco lines in many cases. We also want a greater level of power surety and independence. So if something happens in one part of the grid, we don't want it to affect the other parts of the grid or grids. And we want to be able to support what happens in the grid, the ever increasingly smart grid, where these distributed capabilities can actually help relieve peak demand and support other critical bulk power needs, like frequency support and VAR support and so on, if you're familiar with those utility issues. In any case, it also begs to use a greater amount of direct current. And some people will say, well, why direct current? Well, direct current is the native form of power that's used in most renewable power generation and storage equipment, batteries and solar and so on. And by direct current that isn't alternating, there's no need to frequency synchronize. So therefore, you can really simplify power conversion and control electronics quite a bit. It does improve the efficiency of natively DC equipment like LED lighting and variable speed motors, particularly brushless DC motors, and the use of information technology equipment and other electronic devices. It supports fast charging of vehicles. Again, charging is about typically about charging batteries and other direct current devices. So that helps and allows that to be done more quickly and safely. It also can be used practically at low voltages for touch-safe applications, much like you're probably familiar and not afraid that you're going to get a shock from your cell phone at those low voltages. And perhaps in a hidden way, and more importantly from a technical aspect, the use of DC can help eliminate the electromagnetic noise that comes from alternating currents, and therefore it will avoid the need for shielding and filtering electronics, which will lower costs in general. So how do microgrids work? Well, electricity comes in these two different forms, this DC form, the native form, DC, non-alternating, and the man-made form, which is called alternating current, right? Generally made with rotating generators. The generation, transmission, and distribution has traditionally been based on AC because of the ability to convert voltages in AC, which made it practical to move that power long distances. But at the same time, it put a requirement on the system that everything connected had to be in the same frequency and phase. Typically, it's a 60 hertz cycle, or 60 times a second here in North America, 50 hertz, and occasionally other frequencies around the world. But most renewable sources do use DC, or direct current. They don't have that oscillating. Most anything that's solid state, for the most part, is going to use direct current with no frequency. And also, there's a lot of stuff out there that's AC. So we're not saying we're against AC or anything, but it's not fixed frequency. Like my inverter cooktop, I'm sorry, my induction cooktop, which is an AC device, or even my microwave technically is an AC device. There are many AC devices, but not on that 60 hertz frequency. So even those devices, the AC 60 hertz has to be converted to DC, so it can be synthetically organized into a different frequency. All of this means that there's a lot of conversions going on, and things need to be synchronized if you're going to try to do everything in a pure AC environment. So the job of the microgrid is to combine sources and storage of electricity without the reliance on a grid and without necessarily the reliance on synchronization. Because DC makes it easier and less wasteful to do this, there's a desire to use more DC in a system. Now, if you're going to put all these grids together, you need to manage them somehow, because even though you may not need to synchronize, some cases you'll still need to synchronize if you're going onto the bulk system. But in other cases, you won't need to synchronize, but you do have to manage the flow of electricity, which is going to be based principally on voltages. So there needs to be developed a management system that can effectively do that. Today's electrical system is really two different systems. One is the physical system that generates and hooks up all the consumption points of use of electricity into grids and microgrids. And that system can route power, can switch it, it can convert electricity, and so on and so forth. But it doesn't deal with the transactions of commerce. Like in the internet, I can do commerce on the internet, whereas on my power line, I can't do commerce on it today. I can't buy and sell through the same system. So there is another system called the electricity market, if you will, where electricity is bought and sold and traded. You know, there are buy bids and sales and sell offers and swapping and trades and so on and so forth. Usually this is done a day ahead of time and has to account for weather and other variabilities, because once you buy or sell electricity, since it for the most part is instantaneous, you need to be able to move it effectively, and if it's too hot a day, you won't be able to move as much through the transmission line as on a cold day, for example. So there's a lot of timing issues with the buying and selling of electricity. The notion of transactive energy management really is a notion of combining these two very different functions, the physical function of power and the commercial function, or the economic transactional function related to power, into one system that is massively distributed, meaning there are lots of actors in the system, just like there is in the internet. Literally in the internet today, I think they're talking about 7 to 10 billion transactive actors in the internet, and that's still climbing. It's probably be 100 billion as the Internet of Things goes up and things start transacting information back and forth. But we want this in a real-time management system similar to the internet, and that's what we're calling the Internet, the energy network. If you want to simplify the whole thought process, it's kind of a democratized electricity internet, just like the internet, which is emerging on the basis of millions of, as I call them, the actors, or the prosumers and independent service providers, who are now joining the existing utility infrastructure in the restructured and expanding energy marketplace. So that's what we're talking about when we talk about transactive power. In the physical reality, we know it as smart home microgrids. So individual homes are becoming solar powered or other renewable energy, whether it's hydrogen or wind or solar. Then they become, like I said, the personal power producers, like personal computers of the internet. Those get in, whoops, those, sorry. A little quick on my slide selector there. Those get energy connected into smart communities, and you've heard that term about neighborhoods and so on that would have individual solar homes and then collectively manage that power within a smaller community. Still in a microgrid, still in something that can be partitioned or islanded off the main grid. And the same is true with smart buildings, whether they're commercial or government, what have you, or even enterprise microgrids that are campuses and military bases and so on. Same concept, on-site power to supplement or complement what is maybe available in the bulk power system off the grid, but needing to have this kind of real-time relationship, both in terms of physical transfer of power as well as transactionally commercial. That all gets energy connected into smart cities. Again, a term that you're probably starting to hear more and more about. You bring in some of the other smart activities within a municipality or a city, but definitely including commercial microgrid campuses and so on. Add that to what the utilities are doing with smart grid, of adding microgrids in many different forms throughout the existing smart grid, and not just at low voltages like we use in the home or the commercial building, but at medium and high voltages. And this includes, things like peaking plants and solar farms and substation voltage and frequency support capability, and what they call black start, emergency backup, peaking, and wind farms and so on. There's a lot going on at the utility level with different types of microgrids, all enabling this sort of grid of grids infrastructure when you connect it all together that is begging for this transactive energy capability between all of these actors in the system. So we are seeing, whether we recognize it fully yet or not, we are seeing a very rapidly emerging smart energy marketplace, which is made up of a whole new set of structural elements in particularly in the electricity domain, but touching on transportation and buildings and all the different activities related to the work that's done by energy. So that's where Solar Power International, the show in the context of what we are now calling North America Smart Energy Week, which is a combination of other things I'll talk about in a second. We have wanted to demonstrate a real smart energy microgrid and what's available in the marketplace right at the show, and power part of the show with that capability. And that's what we're doing. We started it last year. It was an outdoor pavilion, so it wasn't connected to the main floor. This year, it's going to be indoors in the main floor, so we're going to power more things and be more available to everybody. We're going to demonstrate not only generation sources like solar power, but also all the conversion equipment and the storage capability and the load management associated with the microgrid. It'll be contained in what's now called the Smart Energy Hall, which includes the microgrid area, the hydrogen area, and a portion of the energy storage area. It will have its own smart energy stage or theater, which will include presentations from the industry groups like SEA and SEPA, which I'll talk about in a little bit, from exhibitors and from expert panel sessions each day of the show. There are destination tours that you can sign up for that include the smart energy and energy storage track that will get you to all of the areas that we're talking about, and also VIP tours that if you have a group or other international or government or other group that you think is worthy of a VIP tour, please let us know and we'll try to accommodate that. There will be a grand opening on Monday, the opening day of the show, with a little bit of ceremony and fun. And there'll be some keynote presentations at that point. And we're hoping to have a nice after-hours event, either as part of the whole show or as part of the area itself. So this area called the Smart Energy Microgrid Marketplace is comprised of a couple different elements. The most important of which is the microgrid demonstration itself. These pictures are from last year's demonstration, where you see it was contained in its own little building. But it included the outdoor elements, the indoor elements, some monitoring and dashboard elements, and so on. And we're expanding on that theme, only again, we're bringing it onto the main floor and be powering a bigger portion of the trade show floor with the on-site renewable energy. So that's our main focus of that. And I'll talk about the specific things you're going to see there in a second. The Smart Energy stage, or the theater that's right adjacent to the demonstration, will feature, as I mentioned, the opening ceremony, some keynote, some microgrid technology presentations. We're going to touch on regulatory and business model presentations, which I think will be very interesting for those of you who say, where is this going from a regulatory and business standpoint? And we'll hear from panels of experts at the end of each day, or toward the end of each day, that will discuss some of the presentations that were made during the day and other things going on at the show. There will be an online advanced schedule of those presentations, so you can check your mobile app for SPI to see exactly what presentations are going to be in the microgrid stage. And some of those presentations will come from the sponsoring organizations, the Solar Energy Industry Association and the Smart Electric Power Alliance. All of the presentations in the theater will be hosted by our very fun and interesting Austin AC/DC Powers. Kind of got Austin to change his name and brand himself with what we're doing here. So he's going to be along for some fun and lead the charge. A lot of this is tied into the SPI educational program, a very sought after program at Solar Power International each year. But in addition to the normal educational program, we're going to feature a mini lecture, an expert led tour of the Smart Energy Microgrid Marketplace, and those are going to happen on Tuesday. Now, the Education Lounge for those, this is at Mandalay Bay this year. So they're upstairs, and they will feature in the lounge up there where the break area is for the educational program. There will be a graphics replica of the microgrid demo that's downstairs with the viewable dashboard, and that'll be available all 3 days of the educational program. The lecture portion that takes place upstairs will happen on Tuesday at 10:30, 12:30, and 3:30. And after each of those mini presentations, there'll be a guided tour down to the show floor to the microgrid area. So if you're interested in that, you can participate there. SEPA this year has a special Sunday program that's part of the microgrid work group out of SEPA. They're doing a full-day workshop on Sunday. It's an all-day event. There will be a special lecture and tour at the conclusion of that program. It'll be about a 30-minute lecture, followed by up to a 1-hour tour if you're interested in really kicking the tires that hard. But the tour will be expert-led, and it'll take you again down to the marketplace on the show floor prior to it opening to the public. So it's a little bit of a preview. So now I get to the good stuff. These are this year's participants in the microgrid, and I'll talk a little bit about each company and what they're doing in the microgrid. But you see Bosch, CE Plus T-Power, NSYNC Energy Systems, LG, Next Tech Power Systems, Panasonic Solar, DC Fusion, Renesas, the semiconductor company, Solar Mass, a BIPV company, and Universal Electric Corporation. Now, so I call them the top 10 suppliers because they make up the bulk of what is going to be included in the microgrid. I'm not rating them in terms of their products or anything. You'll have to make those judgments for yourself, as the marketplace always does. But they are the top 10 providers of equipment for the microgrid. So you probably know Bosch already. Bosch has a long history in the electrical field, particularly in the transportation sector, but also with semiconductors and other electronics. And now they have expanded their scope out into the power distribution architectures in commercial buildings. So they make full systems, and some of the equipment that they use in those systems will be on display in the microgrid area. And I think particularly we're going to see some unique lighting that runs off of DC at high voltages, as well as there'll be Bosch representatives there in their booth to talk about all of the things that Bosch does, including bidirectional power management, DC drivers, circuit breakers, all the different things that you ever wanted to know about a DC microgrid, which can also use inverters and supply AC as well. We'll also have CE plus T, now traditional critical power company, which has for a long time been involved in AC architectures, but now has expanded their line in enhanced conversion, which they're used to doing to provide power for DC products, but now to actually run DC microgrids. And we'll see their newest offering in what they call their ECI product line, their enhanced conversion innovations. Particularly, we're going to see something at the 380 volt level, which is called the Bravo ECI. Just a little note, they were also the winners of the Little Box Challenge that Google held for power conversion. So they're pretty expert at very high efficiency power conversion. So it'll be interesting to see what they have, and what they're doing is brand new for this year and will be a part of the microgrid. One of our real anchor companies, and they were the pretty much the premier provider last year, and will do so the same this year with a complete system called the Matrix Energy Management System from NSYNC Energy Systems. Some of you may know that they have been leaders in the battery field in flow batteries, but also now they have hybrid batteries that handle a variety of battery technologies in association with their Matrix Energy Management System, which you see here in the center on the slide. All of this is managed by some new software and monitoring equipment called Durflex, or Distributed Energy Resource Flexible Systems. Again, we'll hear a lot about that. They will be running a live energy dashboard at the show, and will be one of the primary providers of power in a complete system. As far as energy supply, we have a number of different solar suppliers. One is LG. We'll have a set of LG panels based on their neon technology that will be outdoors supplying some of the power. So if you're familiar with the LG equipment, sorry about that again. We'll also, on the down conversion of power, both AC and DC at lower voltage levels, Next Tech Power Systems, a long time supplier now of integrated control and power systems for inside of buildings, both commercial and residential. They're in the first ever DC home that's up in Dearborn, or up in Detroit, Michigan. But they're in a variety of commercial institutions and hospitals and so on with their distributed DC technology that's running everything from digital shelf edges in grocery stores to lighting systems to IT equipment, et cetera, et cetera. So Next Tech will be with us again, and they will be supplying distribution equipment for some of the demonstration in the smart area. Panasonic, another panel supplier of the latest in photovoltaics, will be providing another set of panels that will be another source of our power on site. And as you know, Panasonic continues to evolve its technology into a number of different high-performing areas. A new participant this year is a company that you may or may not know. Renesas is one of the largest semiconductor companies in the world, based out of Tokyo, Japan, but has a rather large North American presence. You can see that they have a broad base of application products in automotive, industrial, and broad-based energy systems. They will be demonstrating some power line communication products over DC lines, and also some multi-channel DC to DC product concepts that you'll very much want to hear about, as most of the DC to DC conversions today are single channel. So they have some really exciting new stuff. Another very interesting BIPV supplier is SolarMass. If you didn't get to see them at SPI last year, they're continuing to evolve their product and selections. They're really one of the most interesting BIPV products, in the sense that their product installs almost like a traditional roofing product without penetrating the waterproof membranes of roofs. but electrically connected. And because the panels are relatively small, they can actually occupy more surface area on a roof space because they can get around chimneys and peaks and different shapes of roofs. So a very interesting product that we'll be powering part of the microgrid with. Part of the connection of power equipment inside, particularly the microgrid itself, the microgrid control area, which includes batteries and battery and conversion equipment and distribution equipment, will be Universal Electric Starline bus systems. Some of you may be familiar with Starline from their work in the computer field. They're a very a premier supplier of busway for computer systems, and we're the first to really perfect the multi-channel DC bus architecture in data centers, and also in lighting products, which traditionally, again, were AC, and now they make a very interesting, lightweight, integrated. It's like having the Unistrut integrated into the track lighting, if you will, but done all in DC at higher voltages. So it's good for warehouse and high bay lighting and big box stores and so on. You see up in the thing. And their newest product line, which is sub-metering, which is a part that's included typically in a busway in the AC world, but has been lacking in the DC world. And they have some exciting new equipment to show there. All of this will be put together and engineered by our friends from DC Fusion, who is a consulting group that really are one of the true pioneers of DC architecture, whether it's in data centers or military bases and so on and so forth. And Dave Geary, our principal engineer, will be orchestrating all of the events of the microgrid and its operation, its construction and operation, design. And he's a licensed professional that will be, again, managing the whole effort. So if you are interested in how all this gets done, or if you want to connect a whole bunch of different people's equipment together for buildings or microgrids of any type, DC Fusion is a good example of a company that's moving in that direction. Again, I'd like to acknowledge at this point the contribution of the resources that all these companies have put together to allow us to bring you this live operating microgrid at Solar Power International 2017 as part of North America Smart Energy Week. And at this point, I'm going to take a long breath and a pause and ask if there are any questions. And Greg, maybe you can help me out and let me know if there are some questions.
Thanks, Brian. So there are a couple questions here. I'll throw actually a softball at you, but it might be a lot harder than what it seems. If you were to come to SPI and maybe specifically the smart energy microgrid marketplace, what's the one thing you need to see?
Well, I think you need to see the demo. I mean, the whole idea, it's easy to go to a trade show or a conference and put up a PowerPoint set of slides and show people, how things are wonderful and all that and how they work. But it's another thing to actually see a live microgrid actually powering part of a trade show. This all came out of standing on a trade show floor one day and saying, we all talk about this renewable energy and solar power and all that, and yet we're sitting in a convention center that's running on the age-old tried and true tradition of AC power without renewable energy for the most part. Now, some of that's changed in the last few years, and convention centers more and more are putting solar and other renewable energy sources into play. But to go to a trade show and see a real live operating system, we're going to show you it go through different modes, like islanding, running on battery, running on a combination of battery and AC converted power, or a combination of battery and solar power. So all of the different modes that you might see in an emergency or a planned transactional environment with a microgrid, we'll be able to demonstrate from time to time during the 3 days of the show. Hopefully not by necessity, although I'll tell you a little aside, because Greg probably won't, but he's working from home today because in his office, which is located in Virginia, outside of Washington. They lost power today, and they all got sent home. So a whole day of potentially, with the exception of Greg at least.
Yeah, it's good timing.
Productivity and all. But you know, the things like that happen. Now, if Greg's building were on a microgrid, because actually the power loss, at least reportedly, came from a traffic accident that wiped out some of the infrastructure in his area, but caused the whole section to go down. If they were on a microgrid and had some storage backup, they'd probably still be operating happily, at least happily for the management.
All right. We have another question here, Brian. This relates back to the internet idea. So someone said their perception is that customers just want to have access to reliable and low price energy, which is true. How do you go over this barrier and put the internet idea inside the customer's head? So they also put the caveat in here that they see a blue ocean here. You know, there's a lot of opportunity ways to go about this, but how do you show value in a simple way?
Yeah. I think the one thing that I talk about a lot is the simile between internet and this energy network. If you ask people back in the early 80s and early 90s, you know, what value they thought they would get from the internet before Facebook and Amazon and eBay and, you know, all the things before trading, you know, messages and so on and so forth. Most people couldn't even think of those applications prior to having them, you know, put in front of them. So if they can remember how important it was to have this kind of transactional network associated with energy, and energy is just as important as information. In fact, most people would say information without energy doesn't do you any good. If you can't act on something, if you can't make something, if you can't do work and create wealth, which again, then can lead to the development of sustainable well-being in a society, you really no place. You know, you're a dreamer, essentially. So the idea is that the internet is the muscle to be added to the internet to use that intelligence to do things better, faster, and more effectively for people, whether it's in medicine or whether it's in climate or, as I call it, enhanced reality, health reasons for better lighting, and all the different things that the Internet of Things will bring, and so on. All of those things require management of energy as well. So they're really tied inexorably together. So if we want the kind of benefits from the physical world that we got from the intellectual world of the internet, then we really want to have this internet happen. And that's what I try to convince people of. It's a little bit hard because again, I don't think anybody, when we saw the first personal computers and when we saw the first networks, you know, in an office and so on and so forth, that anybody would think we would be where we are today with cell phones and iPads and Internet of Things and smart homes and smart buildings. Hopefully they'll see the beginnings of it and see some of the initial benefits, which is really good energy management, good management of the environment, and some of the basics. But I think that's just scratching the surface as to what capability will really evolve, what innovation will really evolve out of an energy network like this.
Okay. If anyone has any other questions, please ask in the Q&A area or chat us. Just some housekeeping for Ask. There will be a recording available afterwards of this webinar that we'll send out. And we'll also send the first 2 webinar links so that if you have any interest in learning more about those, you can watch those on your own time.
Greg, while we're waiting for questions, I have just a couple of other slides that people can sort of follow what's going on at North America Smart Energy Week at the web page. And it's again, all you have to do is Google North America Smart Energy Week, or you can Google SolarPowerInternational.com and get on the internet. You'll see here in the North America Smart Energy Week webpage in particular, you see these 4 iconic areas, Solar Power International, which is the traditional base of the show and conference. But this year expanded into the largest energy storage trade show, Energy Storage International. It will include also Europe's largest hydrogen fair, which is coming to the show in the form of the hydrogen fuel cell exhibition, as well as this smart energy microgrid marketplace that we just reviewed. So go to the website and you can kind of follow leading right up to the show again, which is September 10th through the 13th. If you want to get more detail on the smart energy marketplace, and it's not too late to get involved in exhibiting or demonstrating stuff at the show, you can contact us. And an easy way to do that is you just jump on the Solar Power International website, click on the Smart Energy Microgrid Marketplace, and there's some references there on how to get in touch with us. So a lot is going on at the show. It is, in my opinion, the premier show in this whole sector. It's the one show that combines everything together, you know, solar, renewable, fuel cells, microgrids, energy storage, in the context that people can start to wrap their head around how does all this stuff work together and where are we going with this and what's it going to lead to. So I think you're going to see that this show will continue to expand and will be the place to get the latest possible information. And by the way, I want to go back to that one question you said, what's the must see or whatever at the show? I would add to my comments about seeing a demonstration. This is a time that you can find real experts from the companies, the 10 listed and all the others that will surround us. Real experts will be there to answer questions on how they can help you do what you want to do with a microgrid or with your interconnection with the grid. So it's the place to go. You don't have to sort through, you know, some of these companies are very large, and if you don't see their experts in a particular field, sometimes you don't get through very easily. So here's a chance to get through to the real experts in the microgrid domain and learn about what they can do for you.
Yeah, and I would say that's really where SPI has evolved into as well, getting into smart energy storage, fuel neutral energy storage that this year is as well, hydrogen. And tomorrow we're actually going to launch a technical symposium. So that's in addition to our other educational offerings this year, more focused on the science and some standards behind more of the technical aspects that solar and storage come in. So look for that to likely launch tomorrow and be sent out to everyone. There's another question about live streaming. So this year we won't be live streaming. We haven't really done that in the past either. The most that we have done is on social media. Sometimes we do hop in on a live stream and share parts of it, but it definitely won't be like a subscription-based opportunity to do that. So in order to, like Brian said, really interact and engage with these companies, you really have to be on site. And from the educational standpoint, because there's a whole stage and keynotes, you have to show up in order to really see it. But it is on the expo floor. So for getting a pass, if you do go to SolarPowerInternational.com, there's different levels from full conference to expo hall only, and you can make your selection there.
Yeah, and you might mention, Greg, that Solar Power International holds events of various types all throughout the year. This is the premier event, of course, that has the most comprehensive conference along with the exhibitions. But there are other opportunities, smaller venues and so on, for education and experience. But if I had to pick one show to go to that deals into renewable energy, microgrids, et cetera, this would be it. And then you can supplement it with some of the other shows that are related to it, in particular some of the other events that SPI holds.
Okay. One last question here, Brian, unless if one pops in. There's someone asked, who's from Istanbul, wondering to hear the future of Ethernet and smart microgrid. So like from their standpoint, from I guess a more developing, how does that view compared to someone who's more advanced?
Sure. Actually, I happen to be, eMERGE happens to be a sponsor of the IEEE 2030.10 effort for remote access or electricity access. And this availability of electricity in areas where no electricity is available at all at this point is a key capability that these small version microgrids can accomplish. So we've been working on standards to bring smaller versions of microgrids down to personal levels where you would just have maybe 100 or 200 watts of power capability coming off a single solar panel to power some lighting and some other small appliances, a fan or whatever in a hut or home. And that can, importantly, not just be that, but evolve to something in a more developed way over time. So we would expect that as people can do more work and better work with not only access to the cellular system through their cell phone, but also through some use of electricity, that their economy in general will start to improve. And as they do, they're going to want to invest in more and more resource to enable that growth. So we'll have some, in the poster area of the show, we'll have some discussion about electricity access and how that's evolving. And I personally would be happy to, I just got back from Africa not too long ago in a conference in Germany on this subject. So I would be happy to engage anybody in the discussion and get them involved in what we're doing in that field. But it all ties into the same thing. This internet that I talk about is a global effort. It's not just a US effort or a German effort or, you know, Japanese effort, whatever. It is global. And in fact, probably if you talk in relative terms, the biggest relative benefit will come to people who don't have any electricity today. They have the biggest potential. And I think it's estimated that, for example, in Africa, that 2 or 3 billion people between now and 2030 will be added to the population in Africa, which, for those of you who are not aware, has a landmass that's 2 or 3 times the size of the United States. So that's a lot of people, and just to add them without the benefit of electricity and the ability to do advanced work, or even just power their cell phone, is kind of a scary thought. So we definitely want to get people engaged in the developing areas of the world in the same way that they became available cell phones. It was amazing to me to find out that most of the people that I met in Africa, and I was out in the bush, had cell phones that operated off of cell towers and satellite cell capability. What they didn't have is electricity to do any work, so they're still burning kerosene and wood and other things. So we have a long way to go there, but it can happen very quickly if we move into this kind of energy network infrastructure that does not specifically rely on the grid. Although I'm not a grid basher, I think the grid is absolutely required and wonderful, and there's a tremendous advantage in a system. You don't have to start with a grid. You can start with isolated microgrids, and just like you would a computer without networking it, and then add the network and all the way up to an internet. So we built the big power systems of the world were built from the top down. There's no reason today that you can't build it from the bottom up. In fact, it would. I would suggest that it's probably easier to build it from the bottom up than the top down.
Okay, thanks, Brian. One last question here before we sign off. You said, do you see plug-and-play style solar panel installations in the future? And is there anyone working on those right now?
I am aware that there are several companies that are working on plug-and-play solar. And I think, like everything else, innovations like that will have a place in the market. When anybody asks me about certain things that seem logical but maybe not aren't all that visible yet, I say, you know, it's going to have a place in the market. I don't know what percentage of the market that plug and play will take on, you know, because it's still, you know, heavier equipment and so on and so forth, depending. But for a small installation, plug and play is really nice.
All right. Well, I think that's all the time we have today.
Greg, just along that same line, and talk about innovation. I'm a bit of a tinkerer myself, and just to add, for those of you are curious about small systems, I actually raise honeybees. So I have several beehives, and I've converted my beehives to solar-powered beehives. And people kind of joke, "What does that mean?" Well, it's this, small solar panel that provides a little extra heat in the winter and a little extra cooling in the summer, so the bees don't have to work so hard. And it also provides me camera access, so I can see the bees without opening the hive and make sure that the various diseases and other maladies that can happen in a hive don't happen. So it's just one small, tiny example of how this sort of internet capability, whether it's small like beehives or big like communities or cities, can evolve over time. And I think you're going to see all that innovation once we have the right infrastructure.
Okay. I don't see any other questions. So thank you, everyone who joined us today. We will send a follow-up email, like I said, with the first 2 webinars, and once we get the video recording up of this one as well. If you have any questions, feel free to visit solarpowerinternational.com, or when we send out that email, just feel free to reply, and I'll have my email address on there. And if you're looking to get involved in the smart energy microgrid marketplace, I can forward your contact information over to Brian. Definitely the sooner the better, because we're actually only a couple weeks out of SPI and even September. So really the planning needs to be finalized probably in the next week or so. So thank you all, and have a good day.